Hi all, thank you for your interest in our work. My name is Gopika Jaykumar. I'm a PhD student at the Intuitive Computing Laboratory at Johns Hopkins University, and today I will be presenting our work on structuring human-robot interactions via interaction conventions. As more types of robots begin to make their way into various environments, the question of how people may best interact with robots becomes more complex. My research goal is to enable end users of robots to tackle this growing complexity by providing them with tools to intuitively collaborate with, instruct, and program robots. A traditional approach towards creating more effective human-robot interactions has been to model human-robot interaction off human-human interaction, with the robot being responsible for understanding multi-channeled, open-ended human behaviors and interaction contexts, along with displaying human-like behavior. While this approach creates a more seamless and familiar interaction, it places a substantial algorithmic and computational burden on the robot in terms of understanding spontaneous, unbounded, and diverse interaction scenarios. As a result, human-robot interaction based off human-human interactions may become unfeasible, particularly outside of the research lab in uncontrolled settings and longer-term deployments. Furthermore, human behavior and human-robot interactions may be dependent upon different human characteristics, like culture, educational background, or gender. Therefore, a robot should tailor their behavior to individuals while following cultural norms and avoiding discriminatory or stereotyping behaviors. In reality, most robots do not have the flexibility or capabilities to adapt their behavior to every individual. As a result, end users may have to alter their own behavior to effectively interact with robots, or in the worst case, may be completely hindered from interacting with the robot. In the same vein, end users may have the additional cognitive burden of learning new interaction patterns for each robot that they interact with, since different robot platforms and manufacturers may have different interaction capabilities and standards. Is there an alternate approach to designing interactions that are more feasible, easier, and universal? Actually, we have this type of interaction every day, though not necessarily with robots. We constantly have easy-to-use standardized interactions with computing interfaces, such as touch screens on mobile devices. These interactions, such as pinching to zoom or swiping to scroll, are largely not based on any natural behaviors that we exhibit, but are instead based on conventions that we have learned over time. These human-computer interaction conventions enable users to work with a device despite its technological limitations, such as small screen size, and are universal despite differing device manufacturers and user locations. In this talk, I will discuss our work on applying interaction conventions that users can learn to human-robot interaction to create more universal, adaptable interactions between end users and robots. To discover the feasibility of applying interaction conventions in order to structure interactions between humans and robots, we developed a multimodal convention called Put That Here that allows end users to instruct a robot manipulator to perform tabletop pick-and-place tasks. Here we show example uses of our interaction convention. Our interaction convention is modeled off of natural implicit human multimodal behaviors and allows users to use 4 classes of one-handed or two-handed hand gestures to select objects and to specify the locations they should move to, along with allowing users to verbally specify task actions, such as move or pick up. We developed an autonomous robot system that operates on this convention. The system uses projected feedback to indicate its interpretations of user task specifications. Here we show an example of how an end user may use the Put That Here interaction convention. In order to gauge whether users were able to easily and effectively learn to use the put that here interaction convention, we conducted a user evaluation with 3 conditions. One in which users used put that here, a second where users instructed the robot using only speech, and a third where users instructed the robot using only gestures. We used a within subjects design with 10 participants in which condition order was counterbalanced. We found that users were quickly able to pick up our interaction convention and used it with ease. Compared to speech-only interaction, our interaction convention resulted in higher task efficiency, lower cognitive load, and higher usability for users. Furthermore, we found that our interaction convention better paralleled natural human instruction methods compared to gesture-only instruction. Our interaction convention was the most preferred instruction method, with users mentioning the convenience and ease of use as factors that made put that here preferable. In summary, just as new interactive technologies such as touch screens require interaction conventions such as hold and release or drag and drop, we argue that robots require interaction conventions for effective human-robot interaction. In this work, we explored one such interaction convention, put that here. Our evaluation revealed the usability and learnability of this multimodal convention, highlighting the potential of applying learned interaction conventions to human-robot interaction, particularly for novel, cross-cultural, or technologically limited robotic technologies. Thank you for listening to our talk. For additional information about our work, please refer to our work in the conference proceedings and feel free to reach out to us via email.